Casio, trigonometric ratio.
Hi guys! Welcome back to another video on our Casio Tech Talks. And for today, we will discuss a grade 9 topic which is about trigonometric ratios. Now, from the word itself, trigonometry is a branch of mathematics which studies about the relationship between sides and angles of a triangle. Now, let's first discuss what are the trigonometric ratios and how are they been defined. From the word itself, ratio. So ratio in our grade school is simply the relationship of two quantities. Now, what we are dealing with here is the relationship of two sides of a right triangle, which is related to its angle values. As you can see here, we have a right triangle A, B, and C, where the angle C is the right angle. Now, to define our trigonometric ratio, we need first to define which angle will they constitute into. Now, we will select angle A as our reference angle. Now, from here, we will define each sides. Now, from our angle A, the side which is adjacent to it, we will call it as the adjacent side, and we will name it as side A. Now, the side opposite to the angle, which is side BC, let's name it as the opposite side and side O. While the longest side, as we know, the longest side of a right triangle is called the hypotenuse, and we will name it as side H. Now, in creating the ratio of these two sides, we will get two sides and their defined values. Now, we can select two of those sides and let's create their ratio. Okay? Now, let's select the opposite side and the hypotenuse, so that the ratio of it will be O is to H. And then I will select adjacent side and the hypotenuse, and that will be the ratio of A is to H. Now, if you remember in our grade school, okay, we can define ratio as a fractions. So I will define the ratio as fractions. Then I can select the opposite side and the adjacent side to create the ratio, and then we have O is to A. Now, I will select three other ratios, and that will be H is to O, H is to A, and A is to O. Now, we have all the possible ratio of the sides of the right triangle. Now, here comes the trigonometric functions, or to define each of these trigonometric ratios. Now, the ratio of O over H is simply called as the sine function, and then A, the ratio of A and the hypotenuse is called the cosine function. The ratio of opposite side and the adjacent side is called the tangent. Now, each of these trigonometric functions constitute to the angle reference to each of the sides. Now, let us put into the angle, which is the sine theta, cosine theta, and the tangent theta, as we define our angle A as our reference angle theta with respect to the opposite, adjacent, and hypotenuse. Now, take note, if the angle reference will be at angle B, take note, adjacent and opposite side will be reversed. Since if the angle reference is at angle B, the adjacent side now is side BC, and the opposite side now will be side AC. Now, our reference angle is angle A, so therefore the opposite side remains at BC and the adjacent side remains at side AC. Now, let's take a look at the three other trigonometric ratios. Now, H over O, or the ratio of the hypotenuse over the opposite side, is named as cosecant. Then, let's put our angle theta. And then, the ratio of hypotenuse and adjacent is called the secant, the function of secant. And then, the ratio of adjacent side is to the opposite side is named as cotangent. Okay, and don't forget to put the equal sign. Now, we have defined the sixth trigonometric ratio according to its definition, which is the ratio or the relationship of the sides and their angles of a triangle. Now, let's apply this trigonometric ratio and find each one of them given a certain right triangle. Now, we have here on our first example, so we have a triangle. This is the reference angle. So, for us to get this done easier, let's name each of our vertex as A, B, and C. Okay? Now, our reference angle is angle A. So, therefore, 6 here is our opposite side and 8 here is our adjacent side. Now, our side AB doesn't have a value yet, but side AB is our hypotenuse. So, now we have our named side A, O, and H. Now, for us to determine the value of H, we will use what we have learned in our third quarter, which is the Pythagorean theorem. Now, Pythagorean theorem states that the sum of the squares of the two sides of a right triangle is equal to the square of the longest side called hypotenuse. So now, given that theorem, we define our values or our equation using our given values. Now, it is said that the sum of the squares of the two sides, our two sides here is the adjacent side and the opposite side. So, sum of the squares, so that will be A squared plus the opposite side O squared is equal to the square of the longest side called hypotenuse. So now we have our equation. Now let's solve for our hypotenuse. So our value of A is 8. Now 8 squared plus the value of our opposite side is 6. So that is 6 squared equals the square of the hypotenuse. We do not have the value yet. So let's define it as H squared. Now let's continue solving. 8 squared is 64 plus 6 squared is 36 and H squared remains H squared. And let's simplify. So 64 plus 36 is 100 and we get it's the root of both sides of the equation, and we have our value of H to be equal to 10. Now, we know that the square root of a number is either positive or negative. But in this case, since we are dealing with a measurement, and the measurement of sides of triangle cannot be negative, so we have our value of our H to be 10. Okay? So now, we have defined the value of our H to be equal to 10. Now, let's go back to our trigonometric ratio. Now, let's define our sine theta. So, our sine theta is equal to the opposite side over our hypotenuse. So, that will be our opposite side is 6 and our hypotenuse is 10. Now, we always need to get the simplified value of our fractions. So 6 over 10 is divisible by 2 for the numerator and denominator. That is why we can simplify this as 3 over 5. Okay? Now, let's go to cosine. Our cosine function, cosine theta, is equal to adjacent side over hypotenuse. Our adjacent side is 8 and our hypotenuse is 10. So let's simplify again our fraction. 8 over 10 is both divisible by 2. So that will be 4 over 5. Now, let us define our tangent theta. Again, tangent theta here. Oops. I'll use the blue ball. Tangent theta to be equal to the opposite over adjacent side, which is 6 over 8. And 6 and 8 is both divisible by 2, and that will be 3 over 4. Okay? Now, let's go with our cosecant, secant, and cotangent. If we can see here, sine is opposite over hypotenuse, while cosecant is hypotenuse over opposite. So as you can see, O over H and H over O are reciprocal of each other. Now, using that idea, we can define that cosecant theta is simply the reciprocal of sine theta. Okay, so let's go with our cosecant theta. So since cosecant theta is the reciprocal of sine theta, we can just simply get the reciprocal of sine. From 3 over 5, we can get 5 over 3. While secant theta and cosine theta is both the reciprocal of each other, A over H and H over A, we can say that secant theta is the reciprocal of 4/5, which is 5 over 4. Same thing as our tangent and cotangent. Tangent is opposite over adjacent and cotangent is adjacent over opposite. So we can get the inverse of tangent theta or the reciprocal of the tangent theta to get our cotangent. Okay? So cotangent theta is the reciprocal of tangent and our tangent is 3 over 4. Therefore, our cotangent is 4 over 3. Now we have all our 6 trigonometric ratio for this triangle. Now let's do our some computation using our calculator. Now to use our calculator, aside from having the values itself, we can always observe and take note of our reference angle. So to use this function of our calculator, you need to look first with the reference angle and how is the adjacent and the opposite sides are placed. Now for this calculator technique, we will use the polar function, and that will be the function at the top of our addition sign, which is named POL. So to access that, we need to press shift and then the plus sign, and then to put in the numbers, take note that the adjacent side should be put first. So for our first example, we have 8, and then we use the comma, that is the second function of the close parenthesis. So that will be shift, then comma, and then we put in our opposite side like this, and press the close parenthesis and press equal sign. Okay, now take note, r here will be our hypotenuse. Okay, and that is saved under our variable x. And theta here is the value of our reference angle, and that is placed under our y variable. Now, to solve for the different trigonometric ratio, just type in sine and access the y value, which is alpha SD, and press equal sign. So we have here sine theta is equal to 3 over 5. And we get the reciprocal. The reciprocal function is x raised to negative 1. If we press it there, we can get the value of our cosecant. Now, to get cosine, just type in cosine and then alpha SD to access the y variable. And we get our cosine theta to be 4 over 5. And its reciprocal secant theta is 5 over 4. And then tangent theta, so that is tangent. Then access the y variable again. And we get the tangent theta to be equal to 3 over 4. And its reciprocal cotangent theta is equal to 4 over 3. And that's how you use your calculator in solving for the different trigonometric ratio without using Pythagorean theorem or even the SOHCAHTOA. Now, let's try and solve our second equation, or our second triangle. We have here our triangle whose side is 5 and 12 with a missing hypotenuse. Now, let's again define our triangle. So, let's define this as our A, B, and C. If we can observe, our reference angle now is our angle B here. So, therefore, the adjacent side of angle B is 12. Very good. So, we have here our adjacent side, and our opposite side now is side AC. So, let's name it as side O. And then our hypotenuse remains the same. It is the opposite of our right angle. Now, again, we do not have the value of our hypotenuse, so we use our Pythagorean theorem to define and get the value of our hypotenuse. So that will be the sum of the squares of two sides of a right triangle is equal to the square of the longest side called hypotenuse. Okay? Now, we can define it and substitute our given values. So, A is equal to 12 squared plus our opposite side is 5. So, that will be 5 squared. And hypotenuse, we do not have yet the value. Then, let's continue. 12 squared is 144. 5 squared is 25 equals square of hypotenuse. Let's add, that is 169. And then, we extract the root of both sides of the equation to get our value of h to be equal to 13. Okay? So now we have our value of our h, and that is 13. Now, using our trigonometric ratios, if we can remember here, let's define our sine, cosine, and tangent first. Okay? Now, sine theta is equal to opposite over hypotenuse. Now, the opposite side is 5, while the hypotenuse is 13. So, that will be 5 over 13. Then, cosine theta is equal to adjacent over hypotenuse. So, that will be the adjacent side is 12, and the opposite side is 13. Then, we have our tangent theta. Tangent theta is opposite over adjacent. The opposite side is 5. The adjacent side is 12. So, we have here 5 over 13. Now, let's now get the reciprocal function of sine, cosine, and tangent. So the reciprocal of sine is cosecant theta. So therefore, the reciprocal of 5 over 13 is 13 over 5. While the reciprocal of cosine is, we have here the secant. So that will be secant theta is equal to the reciprocal of 12 over 13, which gives us 13 over 12. While we have here tangent theta, the reciprocal of tangent theta is cotangent theta. So therefore, the cotangent theta is simply the reciprocal of this should be 5 over 12 since our adjacent side is 12. So therefore, cotangent theta is the reciprocal of 5 over 12, which gives us 12 over 5. Okay? So that's how we get our sixth trigonometric ratio. And let's find out how we can solve it using our calculator. Now, let's apply our calculator techniques in our second problem. So take note that the reference angle now is angle B. So therefore, our adjacent side will be the side which value of 12 and the opposite side which is 5. So that will be pol 12, the adjacent side, and press comma, then 5 here. Press equals sign. So we have here the value of our hypotenuse, which is 13, and our reference angle, which is 22. 13 is saved in our variable x, and 22.61 and so on is reserved or input in our variable y and save there. Okay, so press AC and use our trigonometric ratio and the variable y to get our sine theta, that is 5 over 13, reciprocal, which is cosecant, which is 13 over 5, cosine y again. So we have our cosine theta, which is 12 over 13, the reciprocal, which is secant theta, is 13 over 12, tangent y is equal to 5 over 12, and the reciprocal, which is the cotangent theta, is 12 over 5. So take note, in using this calculator technique, you should always be mindful which is the adjacent and the opposite side to use the polar function accurately. So guys, that's how you solve or find the different trigonometric ratio using our manual solving here, and then how to find the 6 trigonometric ratios using your calculator. See you on the next video.